It's a very simple protocol. So the idea of stop and wait protocol is very straightforward. And the idea is, after transmitting one frame, the sender waits for an acknowledgement before transmitting the next frame. Suppose if the sender is sending one frame and it won't send the next frame before receiving an acknowledgement from the receiver. But there are chances for the frame to be lost or the acknowledgement to be lost. If that happens, the sender will wait for an infinite amount of time and the receiver will also wait for an infinite amount of time. And there will be no progress in the stop and wait protocol. But how this stop and wait ARQ is differing from stop and wait protocol? It is this. If the acknowledgement does not arrive after a certain period of time, the sender times out and retransmits the original frame. That is, if the sender is sending a frame and that frame is received by the receiver and the receiver is sending an acknowledgement, if that acknowledgement is not reaching the sender on time, so there will be a timer that is running in the sender side. Once the timer expires or the sender times out, immediately the sender will retransmit the frame again. So this retransmission is automatic, and that is why we call this as automatic repeat request protocol. That is stop and wait automatic repeat request protocol. So stop and wait ARQ protocol is simply a stop and wait protocol in terms of concept, but additionally it has a timeout timer and a sequence number of the frame. So when we have the idea of stop and wait protocol, which is inbuilt with this timeout timer and the sequence number, then it is a stop and wait ARQ protocol. Let's see some scenarios. It will be helpful for us to understand stop and wait ARQ protocol in a better way. And we have 4 scenarios here. This is scenario A, B, C and D. As usual, there is a sender and there is a receiver, and sender has a timer, and this is the timeout period. Let's see scenario A first. In scenario A, the acknowledgement is received before the timer expires. It means the sender has received the acknowledgement from the receiver before the timer expires. If we observe the timeline diagram, the sender has sent the frame and the receiver has sent the acknowledgement before the timeout. It means before the timer expires in the sender, we got the acknowledgement. So this is perfect as far as stop and wait protocol is concerned. Let's see scenario B. This is scenario B, where the sender is sending a frame but this frame is lost. So in this scenario, the original frame is lost. So scenario B deals with the original frame is lost. So what happens? The sender has sent the frame and it has not received by the receiver. And obviously receiver will not send any acknowledgement. So the timeout expires here. So the timer expires here and the sender retransmits this frame again, and the acknowledgement for the retransmitted frame is received before the timer expires. This process is automatic. So this is how the stop and wait ARQ is differing from stop and wait protocol. Let's see another situation. This is situation C, where the acknowledgement is lost. Let's see how stop and wait protocol handles this situation. The sender has sent a frame and receiver has sent an acknowledgement, but this acknowledgement is lost and the timer is running out here. This sender is waiting for the timeout to happen. Before the timeout, it didn't receive the acknowledgement. So what happens? The sender retransmits the frame again because the sender assumes that either the frame is lost or the acknowledgement is lost. So after retransmission, the acknowledgement is received before the timeout expires. Scenario C also, the retransmission is automatic. Let's see scenario number 4. In scenario number 4, the frame is not lost and the acknowledgement is also not lost. Then what is the problem with this scenario? This problem is the timeout fires too soon. It means before getting the acknowledgement, the timer expires. Let's see this example. The sender has sent the frame and the receiver has sent the acknowledgement. Due to some delay in the network, this acknowledgement has reached the sender lately. It means the acknowledgement has received after the timer expires. If you notice here in the timeline diagram, we got the acknowledgement after the timeout expires. So what the sender does? It understands that there is a problem either with the frame or the acknowledgement, and it got the acknowledgement late. Once the sender finds out the timer has expired, so it retransmits the frame again and tries to get the acknowledgement for that packet. So this is the situation where the timeout fires too soon. It means before getting the acknowledgement, the timeout expires. So the sender retransmits the frame again and tries to solve this problem to the best. And that's it guys. I hope now